So we'll be continue from where we stopped the last lesson. So first and foremost, we commit our ways unto God and we want God to lead us and direct us also. Now, I hope you guys understood where we stopped. We stopped at this point. So said this force acts on this body at rest. So something at rest, u equals to 0. That is, the object is not moving. So at 0, at rest, u equals to 0. So this is the force. Force equals to mass and acceleration. So how can we get that? Since the thing is at rest, we cannot use this formula. Assuming there is a change in momentum, there is a change. Maybe the object is moving and then being acts to otherwise, being acts by some force to act otherwise. So we can use this formula, but we don't need this formula. So you guys must know that force equals to mass times acceleration. Since we are given the mass, and then to look at the acceleration, the force is given already, so you substitute it. The force equals to, this is our force, 0.6, and this is our mass. So you need to convert this 40 gram to kilogram. So divide by 1000, that's 0.4. So a, the acceleration, so you divide by 0.4. So 0.4 cancel 0.4, because reason why we divide it by 0.4 is that is the coefficient of a, that is number beside a, you divide it by the both side. So when we divide both side by 0.4, so our acceleration will be 15 meter per second. Final answer, square. Looking at this example 2, a truck of mass 3200 kg moving with a velocity of 10 meter per second increases its velocity to 20 meter per second in 5 seconds. So calculate the magnitude of the force exerted on the engine. So let us look at that. So looking at the second question, the truck is moving, the mass of the truck is 3200 kg and moving with this speed. The truck is moving with 10 meter per second speed, and then slow and behold, suddenly the truck increases the speed, matching on acceleration, accelerator. I mean, the driver match on accelerator, and this now causes an increase in the speed from 10 meter per second to 20 meter per second. So the 20 meter per second is the final velocity. This is the initial velocity at which the vehicle, the truck was. So you know that there is a change in velocity there. So changing in velocity in what time? At which time the speed changes? At in what? In 5 seconds. So we need to use this formula. So using this, you must also notice that the engine in the truck is being it exerts some force to increase the speed. So the question asks us to look for the force that is in the engine. It is the force. When you match on accelerator, some force will push the car. So maybe the car is at for instance now the car is at 110 meter per second square. The speed. Now the engine, the force now, there is another force in the engine that now increases the speed from 10 meter per second to 20 meter per second. So we need this formula because there is a change in velocity there. So we now say mass. So we use this formula. So what's our force? We don't know. What's our mass? So you can also write this then. Okay, let's solve it. So open bracket. You can open bracket since m is common at both sides. M is common, so you can take one m, and that's mass. So what's left? You must know that. Let's write it in time. So F equals to 3200 into bracket. What's our V? That is the final velocity. V is the final velocity. U is the initial velocity. You can call it initial. This is final velocity minus the initial velocity is 10. This is 10. So all over in time seconds. In what seconds? The speed changes in 5 seconds. So when we do everything together, so 3200, this is 10. When you subtract 10 from 20, so all over 5. So when you add everything together, will give you 6400 Newton. Final answer. Newton. Final answer.